Hello and welcome to our May edition of Office Hours by BYK Instruments. My name is John Kowalski. I'm part of the marketing team here. And today we have our business line manager for automotive, Ms. Ray Roby, presenting on appearance theory. If you're unfamiliar with our Office Hours format, it's a shortened presentation, usually 20-25 minutes. Then it's just open discussion followed by your questions. So if you have any questions along the way, or if something's been, you know, bugging you for a little bit, just log it in the chat box, and we'll get to that immediately following the presentation. Also, note we are recording this, and immediately following, you'll receive a link to this recording. Feel free to check it out later, share it with colleagues, whatever you like. With that, Ray, you ready to roll?
Yes, I am. Thanks, John. So good afternoon, everyone. Today we're going to talk about appearance theory. And when we talk about appearance theory, there's two main points that we always talk about. It's waviness and brilliance. So waviness can be called orange peel or texture. Brilliance or DUI is usually the finer structures in the coating that's giving you like that fuzzy appearance. And both of these really influence what your appearance is going to look like. So our visual perception is based off of the illumination of whatever we're looking at, and then how that is actually being reflected to our eye. So you can get light or dark patterns depending on where you're standing relative to the part that you're looking at. And it also depends on the angle of illumination. So when we're talking about appearance, like I said before, we have the brilliance or the DOI and the orange peel or the waviness. So depending on our viewing distance, we're going to see different aspects of these two properties. So closer to the part, say 40 centimeters in this example, we're going to see the smaller structures. And this is what's going to influence our DOI or our brilliance of the material. And then say in this example, 3 meters from the part, you're going to see the larger structures or the orange peel and the waviness. And here's an example just to show you of what you see from the different distances. At 40 centimeters, you can see the individual A, B, C, D letters themselves. And the farther away you get from the part, you're going to see more of this pattern and not the individual letters themselves. So this is important when you're looking at appearance, because depending on where you're standing from the vehicle, you're going to see different aspects. So when we look at the actual wavelength, so this is the actual wavelength of the structure itself in millimeters, not a wavelength of light, but the actual physical structure. And when we break these down into different categories from 0.1 to around 15 or 20, we can see the smaller structures, and that would be at 40 centimeters. And when we get farther away from the vehicle, we can see from 1 to say 100 millimeters of wavelength, and that would be at like 3 meter viewing distance. And then underneath 0.1, this is where the resolution of the eye cannot see the individual waves. So this is a different measurement that we also do, and we call it dullness, and I'll talk about that in a little bit. So the instrument, when it measures, you roll it across the surface, and there's a laser inside that is emitted to the surface of the material that you're looking at, and then there's a detector that gives you an optical profile. So if we just had this optical profile, it would be very hard for us to decide what we need to change in our process to improve our appearance. So We broke this down into different categories, but before I explain that, I'm going to show you how the instrument measures. So when it rolls across the surface, you see the sensor, and then different amounts of the light from the laser is getting back into the sensor, depending on where you are on the part. So it changes. The amount that's getting back to the sensor depending on where you are on the part. So originally when we started with the wave scan many years ago, there were basically two mathematical filters that we imposed, long wave and short wave. And then with the advent of new materials for the coatings and new technologies in the industry, we've decided that the long wave, short wave was not enough information. So if we look at these two examples, sample A and sample B, and we just look at short wave and long wave, the short wave on sample A is 15 and the long wave is 10. And on sample B, the short wave is 17 and the long wave is 31. So these two examples are quite different. One has much more long wave than the other, but about the same amount of short wave. And sample A looks a lot better in my opinion. Other people can have different opinions, but and sample B would have more texture associated with it. And this would be the bigger structures that we call orange peel or waviness. This example shows you two samples, one with a short wave of 21 and one with a short wave of 12. And the other one, the long wave values for the sample C is 7 and sample D is 12. So when we have this type of numbers, the numbers are still fairly low, but when you have the ratio of your short wave to your long wave, where your short wave is a little bit higher than your long wave, you get a better appearance than in sample D, where you have equal short wave and long wave, and you just have a lot of structure, and it just doesn't look as good as sample C. So in order to capture all the new technologies in the industry, we've broken the optical profile down into much tighter categories. And this is an example here of what you can see from 0.1 millimeters to 30 millimeters. And when we talk about these ranges, we've broken them down into WA, WB, WC, WD, and WE. So now we're covering from 0.1 millimeters all the way up to 30 millimeters. And originally in the blue area, which is mostly WB in our new structure spectrum, is the short wave, and then WC and WD corresponds fairly well with the long wave. So if I look at the structure curve for sample C and sample D, sample C has two humps, and sample D is kind of straight across and then comes down at the end. So what's important on this slide is that the double hump is giving you a better appearance than the red line, which doesn't really have two humps. We call it double hump, and that's something that we talk about a lot in the industry. In this example, we would really like the WD to be lower than the WB, but since they're closer together, you're still getting not the best appearance that we would like on this sample C. And then sample D just has so much structure, and there's no definition between the long wave and the short wave, and that's why it looks very structured. So DOI, this is what we talked about in the beginning, or the brilliance And basically, it's if you look into a material on a part, you can see your reflection and how distinct that image is. So good distinction of image has a lot of contrast, sharpness, and for poor distinction of image, you would have less contrast, less sharpness, and these two pictures give you a very good example. So we talked about DOI, and then we want to know how that is calculated. And we calculate it with all of the, all the numbers under 1 millimeters of wavelength. And that all goes into a function called the DOI. So what we haven't talked about yet is the dullness value. And in the beginning, when I showed you the graph, you could see the WA through WE, but there was nothing under 0.1 millimeters. So under 0.1 millimeters, there's a lot of light scattering. And again, you can't see the individual waves with your eye, but it does give you a fuzzy appearance. So it's important that we capture this too, because this can affect the overall impression of your vehicle or your part. So for dullness, we take the scatter value over the max value. The max value is the center portion in the red with the red lines. And then everything that's outside of that is the scatter value. And that gives us the dullness value. And the dullness value is very important because a lot of people in the past have used gloss to measure this type of phenomena in their coatings. And gloss is can be changed depending on your reflectivity of the coating itself. And in this example, 2K and 1K, and the refractive index is for the 2K 1.5, and for the 1K about 1.53. And if we were using a gloss meter, we could have two completely different values because gloss is affected by the refractive index. The other part of this that's important is you cannot use a gloss meter easily on a curved surface. You can get a lot of variation. And this instrument with this DU value or dullness value also works on flat or curved surfaces. So now we have the complete structure spectrum, DU through WE. And looking at the full structure spectrum gives us a lot of ways to improve our appearance and modify our process to make sure our appearance is getting better or remains the same. So here's the calculation for the DOI. It's a function of the dullness, the WA and the WB. And on these two graphs, you can see the lower the number for the dullness through WE value gives you a better DOI value. So lower dullness, WA, WB, higher DOI. The higher the dullness, the WA and WB, the lower the DOI. So in most cases, you want these numbers, DU through WE, lower, but you don't want them as low as possible because you wouldn't be able to maintain that finish and then it wouldn't be a balanced structure. So everything that can affect the surface coating, you can have substrate quality, paint materials, process parameters, and there's many, many things that are involved in all these different areas. So we want to use the wave scan as a QC tool to help either recognize these differences and to improve them. So in order to do that, I have an example, and the original panel is quite high waviness. It has a lot of structure. Normally your WB value, which would be the third point from the left should be not more than 30 and hopefully not more than 20. And in this case, it's about 53. So obviously there's just a lot of structure on this panel. If we optimize the clear coat, we can decrease the long wave, which would be the WC and WD. That's influenced mostly by the clear coat. But now we have still all this other structure that we didn't address that's coming from potentially something underneath the clear coat, base coat, or primer application. So if we sand the primer, now we decrease all of that short wave or the roughness of the coating. And now all of our long wave is really dominant in the appearance of this part. So also this is not quite the look we're looking for. So what we need to do now is to add some more final structure or fine structure back in. And so now in this case, we didn't sand the primer quite as much. We left some of that surface texture on the primer. And then when we look at the curve, we see the double humps that we like. And this gives us a balance between the short wave and the long wave and a better appearance on our final product. So in summary for what we just looked at, these are the different curves and how they change. And the curves are what we usually use when we're trying to improve appearance, maintain a process, all those different types of applications. We use the curves and not just a number. And there's a reason why we don't just use a number. Of course, everyone wants something that gives them a pass-fail number, and it's important. And this is an example from GM where they use the R value or the rating number. And their non-premium, premium specs are set differently. This is just what those customers expect from the finish on the vehicle. And if you look at the three pictures at the bottom, one has an R value of 7.1. The next one has an R value of 7.2. And the last one has an R value of 5.7. So when I look at the first two pictures, visually, they're very, very different. But when I look at just the one number, the R value or the rating number, I'm getting almost the same number. And if I look at the one that fails, this one obviously is very, very dull or low DOI, and that's why this number is failing. But if we just went by the R value and we had these two parts put next to each other and looked at them for harmony, you'd have a very big disconnect between these two parts, and it would not look uniform to your customer, and therefore they would, in their mind, believe that it's not as high quality as it could be if these two parts matched each other for appearance. There's other numbers that we use in the industry. And one of the other ones is the CF value or combined Ford. So this is for Ford. And these are the same pictures that we looked at previously for when we optimized the clear coat and the primer application. And in this example, the original panel that we did not like comes in at 36.2, which is a fail according to these specs. And then the last panels are all relatively close to each other, but the appearance, when we look at them, is very, very different, even though technically they pass this CF spec. So it's very important that we pay attention not just to an overall number for appearance, but also the structure spectrum curves, because they're very important in trying to decide what we're going to do in the future. And here is just a kind of a summary of everything that we talked about. One thing that we always do with our customers is we always do a gauge R&R to validate the instrument under their process conditions. Also, it's a laser that generates the profile. It's color independent, the numbers that we get. And also the wave scan characterize the whole surface structure. So the bottom pictures, the 3 pictures, you can see too much shortwave, very, very fuzzy or grainy looking. Where I have a balance between my short and long wave, I look really good. And if I have too much long wave, I'm going to get this much longer wavelength that's going to be showing to my customer, which also is not technically what people like. But I can tell you that depending on where you are in the world, people's preferences for appearance numbers does change. And some people like what we call a wet look, which would be too much long wave, according to this example. But that's something that is definitely a preference by country. And now I'm ready for the questions.
Nice, good job, Ray. I always seem to learn a few things from you, so thank you. Yes, if anyone has questions, please log them in the chat box and we'll get to them. Have one right here from Alex. Should a part be measured in for CF in the horizontal plane or vertical plane and make an average?
Okay, so maybe you can unmute him.
Yeah.
So there's 2 different answers to the question. So if you're painting a horizontal surface and you're baking it horizontally, then it doesn't affect how you measure so much as if you're painting on a vertical surface and baking it vertically. Because then you can have some micro sag in your clear coat that is going to cause you to get a worse reading if you measure up and down, say, on that surface versus left and right. Does that answer your question, Alex?
Alex, I unlocked you, so if you'd like to activate your microphone in the upper right-hand corner, you'll see a red round button with a microphone in it. You can just unmute yourself if you'd like, and let us know if that answered your question, or feel free to elaborate and we can have more discussion. Give him a minute here. Also, another question here, Ray. How many measurements, and feel free, Alex, just to interrupt when you get that unmuted. Ray, how many measurements per location is kind of a recommended standard?
So industry standard is 3 measurements per location, and we want them slightly separated because you don't want to try to measure the same line every single time because you're trying to get what the customer is going to see of that appearance. So you want more of the surface area measured. If you measure a lot of vehicles or a lot of parts, then 1 measurement per location is sufficient. But you just have to remember that you're doing that because you may have an outlier here and there that could affect your overall average for all those parts.
Okay, and when you mean separated, I know it depends on the size of the part, but like let's say a big door panel, are you talking an inch separated or like 6 inches? What's
probably an inch?
Okay.
Separated.
Okay, that helps. Does the measurement direction affect your reading?
And this is a little bit the same as Alex's question, but yeah. I can explain it in a little more detail.
Yeah, please.
So when we do horizontal surfaces, again, because you're baking them horizontally, you're not getting any sag on the clear coat. So everything's laying flat. So again, horizontal panels, it's not as critical to measure both directions. I can tell you that if we're measuring a whole entire vehicle on even the hood, we will do some measurements one direction and some measurements another direction, but that's more based off of the feature lines because you can't roll over them because that's really going to mess up your data.
Yeah.
But verticals, there's actually kind of a debate in the industry right now whether or not measuring, if you're looking at the panel left to right or up and down, is giving you more of what you see visually. I can tell you the number is better if you measure from left to right because you don't pick up on that micro sag from the clear coat when you measure up and down.
Would there be benefit to doing it both ways and taking a look at the numbers there and then making any adjustments?
So it goes back to what you're trying to achieve. Sure. So if you're trying to meet a specification and the specification is written in a way where they measure from left to right, then if you measure from down to up or top to bottom, then you're going to get worse numbers. So you can not meet your specification. If you're doing it to do improvements to maybe the sag resistance on the clear coat to make that more uniform and not have such a difference between the horizontals and the vertical, then yes, you could do the measurements up and down to work on that type of issue in your process.
Okay. Thank you. Yeah, and it was interesting just hearing you talk about just the different, the base coat, clear coat, and how all of those affect, the overall appearance. And by sanding one down slightly, that'll change numbers and maybe get you in more line with, what you're specified to or what your target is. Can, the instrument, the wave scan, be used on low gloss coatings as well?
So right now it cannot be. So it's usually around 50 gloss where you can't use the meter. It's not a definitive number because it's actually based on the dullness number that I showed you earlier. And if the dullness number is, say, over 60, then you can't measure with the wave scan. But currently, we understand that there's a need for this in the industry. So we are working on a prototype instrument that's going to be able to measure lower gloss surfaces.
Nice. And until then, it's, taking a gloss meter or another instrument that has that gloss measurement.
Yes.
Okay.
A lot of people use now I can't think of the name of it. Sorry. Anyway, a profilometer to measure the surface, but it's also destructive. So it's not always the best to use.
Yeah.
And it's complicated to use, and there's a lot of variables that can be changed. So you have to be really careful when you use it.
Yep. Good. Question a little bit on color measurement. Larry's asking, can you elaborate on when to use SCE versus SCI?
He's going to have to.
Is that specular included, excluded?
Oh, I guess it could be that. I didn't think of it that way, but
maybe
if it is specular.
Larry, I've unlocked you. You mind unmuting yourself and elaborating? Is that what it is? Specular included, excluded? Is that your question? The unmute button should be in the upper right-hand corner, a round circle that's red. You can click it and turn it green.
I'm thinking there's a problem with them unmuting.
I don't know why. Yeah.
Well, I'll answer the question as we...
Can you hear me?
Oh, there you are. Yes. Hey, Larry. Welcome.
Oh, can you hear me?
Yes.
We can hear you.
Yeah, okay. Sorry.
Welcome.
Okay. Thank you.
Welcome. Yeah.
Yeah, it's just when measuring color, Usually you choose, for delta E, a setting SCI or SCE. So just wanted to know, there's been some discussion regarding when to use that. When, we measure an SCI, for actual QC inspection. So I was just wondering if you can elaborate on that at all, if there's a difference between the two, if it would be impactful.
So if it's a specific scale, what industry is this?
It's for rail industry. So it would be like be Class A finish for, side of train cars.
So I'm not sure if I'm familiar with that scale, but if is it two different measurements, or is it actually a delta E calculation?
It's a delta E, but there's a setting where you can set it to measure specular component included or specular component excluded.
Yes, so
there's a setting with your spectrophotometer.
Yep, I understand now. Okay, so yes, it's definitely different. It'll be more different on low gloss than on high gloss. But the specular included is going to give you more of what you see visually than the specular excluded. And I might have said that backwards, but I think that's correct.
So included is more what you visually see?
Yes.
Okay, so if you're measuring for QC, then you probably want to use specular component included.
Yes, you want to use the one that gives you the data with the gloss being attributed to the material itself. Yes.
Okay.
That's more for
and
harmony.
If it's not, these are gloss, high gloss parts, but if it's low gloss, would you then switch to SCE?
No, I would do the same thing. Always, if you want something to match something else and you're more worried about the visual, then you want to use like a 45-0 setup. If you're looking at incoming material that doesn't always have the same gloss level, then you'd want to look at like the sphere.
The excluded.
Okay, so
yes.
So if you go with SCI, that's the measurement to use.
That's in my opinion, but again, it could be an industry standard that I'm not aware of. So be careful with what I say, but that's what I would do if I'm trying to make sure something matches itself or another part. Yes.
Okay. All right. Thank you.
Mm-hmm.
You bet. You bet. Can we help you with anything else while we got you on the line?
No, I'm good.
Okay. Great. Thanks for joining.
Thank you.
Thank you.
You bet. Okay, and then I got another question in here. What's the most significant number to use for optimizing your coating for appearance?
So we talked about how everyone wants a pass-fail number, and if it's R value or CF or whatever, those numbers, yes, they're important because that's the specification that either your customer or you have implemented for your QC process, but they're not very helpful in determining what to do with the material or the process to get better appearance. So we always want to go back to the structure spectrum, the DU through the WE, because that gives us a lot more information on what's happening. So like when I showed you that we, adjusted, optimized the clear coat, then we sanded the primer, and the clear coat affected the WC and the WD.
Is this the right slide?
Yeah, go back one though.
Okay, there you go.
There you go. So initially, like I said, we optimize the clear coat, so that affects mostly, oh, sorry. We're already back one more slide. There you go. Yeah. So now we decrease the WC and the WD. And then when we optimize the primer, we can go to the next slide. Now we decrease the WB, the WA, and the WC by increasing or by sanding the primer. So those are kind of what those two services affect. So when we talk about things like WC and under, it's usually WC is a little bit, it could be clear coat or it could be anything under base coat or under clear coat. So base coat, primer, Ad Pro, substrate, phosphate, anything that's underneath the base coat. Mm-hmm. That's all in the DU through WC range. And then anything above WC is usually related to clear coat. It's not quite that simple, but that gives you an idea.
Okay, good. That helps. Other questions? Log them in the chat box here. Love to be able to help when we can. I guess a question from me, Ray. When someone's, maybe they're just starting out they've been doing some color measurement, now they're getting into, more of the appearance realm. What are key things they should look at or pay attention to when setting up an appearance measurement program?
So it always depends on what you're doing it for. If you're doing it to meet a customer specification, then obviously you just need to meet the customer specification. So you would use the structure spectrums to try to understand exactly what's happening so that you can improve your appearance. The interesting thing is, even though all of the single numbers that everyone has come up with in the industry don't necessarily correlate to what you see visually, but when you make improvements to your overall structure curve, you're going to see an improvement in those other numbers too.
Okay.
So, and that's pretty much across the board. When you improve your structure curve, that you're going to get a better number. Did I answer your question? Oh, no.
Yeah.
Okay.
Yeah.
So that's if you're doing that. If you, the biggest thing to me when you're trying to start working on appearance is to have one of us come in and really look at the samples with you and take measurements so you can see from your samples what's changing in the structure spectrum curves. And that gives you much better idea of what to do in the future. Like, this is a good exercise we do with customers all the time. Yeah. And then it gives them a better feeling for what's happening. And then they can use it in their everyday life to improve their appearance. So that would be my first step.
Okay, good. When someone's evaluating appearance, color is definitely a part of that, or are there times where it's strictly appearance and color is not important? And I guess how do those two relate?
So, of course, you can just measure appearance and you can just measure color. If you're looking at the overall look of whatever, their vehicle or your appliance, both of those things are important to what your customer sees. So I don't think you can do one without the other. I mean, of course you can, but I think that's not giving you the total picture.
Right.
But different colors do have different structure spectrum curves just because of the innateness of the coating itself. So if I have a metallic, because the metallic flake is going to disperse the reflection, it's always going to have a higher DU, that dullness number, than say a straight black. So your curves are going to shift based off your color, but I can tell you only certain OEMs spec different color families for different ranges. Some of them, it's just independent of the color. They just want this number, and that's the number that they want. But as far as the structure curves go, you will see difference there.
Okay, good. Thank you. So what other questions? We got about 20 minutes left. If if there's something we can answer for anyone, just log it in the chat box. We are recording this, like I said, immediately following. You'll get an automated link that you can share the recording with colleagues or listen to it later, watch it later. Also, too, if you think of a question after the fact, you can simply hit reply to any of those marketing messages. It'll come to my team, and we'll funnel them to the right technical expert, like Ray and our applications people.
So
Go ahead.
One I just want to say, in our new instruments for appearance, we can now measure harmony between two panels on the instrument and also have that data outputted. So it's like an appearance harmony number, like we used to do color harmony, same idea. And it's something new that's a new feature in our newer software and our newer instruments. I think it's really important because sometimes meeting the spec is not the most practical thing to do. And like you saw in a couple slides down, I can show you again. That's quick. These two have the same R value, but very different appearance. So to have those numbers and the structure curves, one as the standard and one as the new sample, giving you the difference between those two really tells you if you have harmony on your vehicle or your part. And it's so
nice. So other questions, comments? Ray, you got anything else you want to talk about appearance? I know we covered a lot.
I think my biggest thing with all the industries and all the people we've worked with is it's not as simple as people think it is. There's a lot more behind it. And the more you understand, the more you can use the numbers to benefit you to help get a better appearance on whatever product you're selling to your customer. And I think that's important. And that's why we really stress like the educational part of this, because the more you know, the better understanding you're going to have. And the other side to that is if your customer is giving you a specification and maybe it's unrealistic specification for your materials, then you have a better way to explain to them why you can't meet that specification. Things like that.
Yeah, good. Oh, that makes sense. Let's see, we'll give this another minute or so. I don't have any other questions in here. Let's see. Do another question. What's the primary difference between the BYK-I 23 millimeter and the Spectre 2 Profiler?
Oh, so many differences.
Yeah, I know you love the BYK-I.
So BYK-I does multi-angle, and it also does sparkle and graininess. And normally we use this on exterior paint or high gloss paint with micas or metallics in it. The Spectre Guide Profiler, or the Spectre 2 Profiler, it does color, but only for the 45-degree angle. It's a 45-0. It does gloss. It does reflectivity of your hills and your valleys on your textured surfaces. And it also gives you an idea of your topography of your texture. So that instrument's usually used on interior for structured surfaces, like dashboards, things like that. Also on like some wood coatings that have grain, some fabrics that you might have grain to them too that you need to measure. So really, to me, they're two completely different instruments that do two completely different things.
Got it. So this goes back to what are you trying to achieve and what are you trying to do? Good. What instrument would you use to measure orange peel?
or the wave scan.
Wave scan, what you showed here.
Yes.
Perfect. Perfect. Other questions out there? Other cool appearance things, tips and tricks you want to share, Ray?
I think I've shared a lot of them.
Shared all your tricks?
Probably.
Let's see, give it another minute here. Yeah, we're going to be running these office hours on a monthly basis, different topic every month. Plus, we have our 60 minutes presentations. Those are usually run every month, out of our German office, and we also do some here on specific topics. So if you're ever looking for a specific topic, feel free to let us know. And we have a YouTube channel that has all the recordings from previous presentations. You can look at that link will be included in the automated message you get with this recording. So feel free to take a look there. Didn't catch for orange peel measurement. The wave scan instrument is the way to go for that question.
Question?
Yeah, that was the question.
Okay.
To measure orange peel measurement. So
you answered it for me. Thank you.
You're welcome. Yeah. I'm learning. And how does all this stuff play into? I know we have software packages that capture all this data and run analysis and reporting and data sharing. That goes hand in hand, and does the wave scan plug into all those packages and help with harmony with other color data?
Yes. So what we're talking about is for like color data in the industry right now, there's a big push to do data share because people aren't always at the plants or in the office nowadays. So instead of looking at things visually all the time or having to ship parts and having that time delay affect you to get quickly through your process of getting something approved, they do data share, but you can also do it for appearance data. And when you're doing it for appearance data, again, you don't want to compare the one value. If there's a specification written on one value, you do want to look at the structure spectrum curves, because that's going to give you the best idea of if those two parts are going to look good together next to each other. Mm-hmm. So I know I push it a lot, the structure spectrum curves, but I think it's really important if you want to use the instrument to its full abilities.
We got to get a t-shirt for you with
yes
that on it. No, good stuff, Ray. Always appreciate your insight and knowledge here and expertise. Thank you to everyone that's joined us today. Hope you learned something. I definitely did. Like I said, you'll get the recording of this. Also take a look at the YouTube channel if you're interested in other topics. If you have any questions, just hit reply and we'll route it to the right technical expert here. Thank you again, Ray, for your time. And
thank you, everyone.
You bet. Have a great rest of your day, everyone. We'll see you on a future web seminar by BYK Instruments. There we go. See ya. Bye.
Bye-bye.